It's Tim, Pickup Truck Plus SUV Talk, and I'm so excited today. I'm joined by I'm going to call you my friend because I know you watch the channel. I know you appreciate what we're doing here. John Barta, who is the Assistant Chief Engineer of Diesel Engines for General Motors. I wanted to talk to you because I'm very excited. We had press release came out on 8/17 a couple days ago about the ZR2, but in the very back of the press release, we had the new Duramax diesel engine. And as people on this channel know, I am a gigantic fan of this engine, and every time I'm driving, I've loved it. So I'm excited to be able to talk to you about this new engine. So let's launch into this. So when you designed this new engine, you've been in the first generation, now you're in the second generation. You saw some change, you saw some customer feedback. So what's been your impression so far of the engine?
Yeah, well, thanks for having me on, Tim, and having it give us an opportunity to explain what the new engine's about, why it was here and everything. So we've been working on this for even before the first engine launched. This was already in the works to have an upgrade here in 23. The goal was to increase power and torque, to provide some additional. We have some reserve still in the engine, we knew, so we were able to now capitalize on that in 23. So I think you've seen the numbers. We're higher on power. We're up to 305 horsepower. And we've been able to get to 495 pound-feet of torque. So this has been a nice little bump for us. Engine drives really well. We still keep all the goodness of the engine, quietness, smoothness, all of that. And it's been a good uplift of the engine. I mean, it's been we've got some new parts in there which we can talk about here. But that's primarily that was the take on it. We continually are challenged with fuel economy numbers, and emission numbers, and this is a step to make sure that we're still meeting all those as we go forward.
All right, so digging in this a little bit, you went to 495 foot-pounds of torque, 7.76 or 7.6% increase. What I was curious about though was the real big benefit of the first generation was when when max torque happened. It was a really low RPM. Were you able to keep that with this 495, or do we have a little bit different of a torque curve?
It's a little bit different torque curve. One of the reasons we still have the same 460 pound-feet at 1500 RPM. We've been able to now have higher torque at a higher RPM. We've done that we've got some driveline protection stuff, which we have to protect down at low RPMs and low gears. So we've kept the shape of the curve down low. We took advantage of being able to have higher torque at higher RPMs. And with that, we've got a slightly revised cam to help us get there as one of the changes that was in the engine. And so our max power and torque, but powers is still the same, 3750. Torque did move up to 2750. That's okay. The peak, but it's still 460 at 1500 RPM. So you'll still get that, you don't lose anything. You lose nothing with the new engine. It all gets better. So
well, good. It was kicking the pants getting all that torque at 1500 RPMs. That thing moves.
Yeah.
It moves great. So looking at the details they gave us. So let me just say this. Let me clarify something. So the block and everything else didn't change. We just changed a few parts on the engine.
So overall, we've got about on a part count, we've got about 25% of the engine changed. Okay. And so about 75% is carryover. So that is, that kind of helps the context of what this is. So we went after the core items of power generation and torque generation. And there's been a lot of changes, which we've done, just optimization. There's been some changes to parts that have just been for better oil flow or better cooling. We've maybe increased some diameters on a few pipes here and there, just learnings from the first engine, really what we're doing. So if you don't mind, I can go through kind of the highlight of the part change.
Yeah, please.
So probably the biggest one and the core one is the piston changed. Okay, we had aluminum pistons before. We've gone to steel pistons. That piston's a little bit shorter, and so the connecting rods get a little bit longer, and that's primarily where we're able to get more power and more torque that we're getting. With it, we've got new fuel injectors that have a little higher flow. I mean, the amount of fuel you can get into the engine, it's all power and torque, right? So the steel piston helps us take that more power. The injectors now can inject a little more fuel now to get our peak horsepower and torque ratings. Along with that, the steel sleeve liners inside, with those have gone just a little bit thicker. Based on analysis, our compression ratio is up to 15.2 to 1 instead of 15 to 1. Let's see. So some of the other things we've done, we've taken some learnings from the first engine, right? The active thermal management, we've been able to prove. So our coolant control valve, which is really kind of state of the art in terms of cooling in the engine, that guy had 3 different actuators in it. And one of them we found really wasn't contributing a lot. So we've been able to take out one of those actuators in there and still get the same net cooling benefits, and then just reduce the complexity a little bit. So that's a good move, because, if we can reduce the number of these items in the engine, it just overall will help warranty and performance of the motor. So, that's what part of this, excuse me, somebody's pinging me. That's what part of this is all about, just trying to optimize the engine, take the learnings. Other things that have happened on this engine, the cylinder head gasket is a little bit thicker to accommodate some things. The turbo has been retuned primarily to kind of get more of the airflow, so we can get the peak power and horsepower. Let's see. That's the brunt of it. Many of the other things that have changed have been just for some quality improvements here and there.
Okay. Oh, and just real quick to clarify, so the last generation was called LM2. Do you have a new name for this new generation?
So those are randomly generated RPO code, regular production option codes, I think is what the acronym is for. And the next one available was LZ0. So I don't have any say over that. That's just kind of, sent out. The L does stand for line engine, but the next 2 digits are, I don't know if there's any rhyme or reason to them. So
actually, I think it's one of the best things about your diesel engines. They all have different, it's easier for me, right? So then I'm talking to the customer, or the viewer, whatever, I can say this, I can say those letters and people, okay, they know that engine is. So I frankly like it. All right. So let me ask you this. You put the thing in improved temperature control features. We've talked about temperature as well. Because I remember when the first generation came out, there was some initial conversations about it running hot. And I know there was a addition that was added to the owner's manual to say, hey guys, this diesel does run a little bit hot or whatever. I mean, was that part of the direction on doing that, or are you trying to get better J2807 standards for towing to keep the engine cooler longer?
So I think the cooling enhancements I just kind of briefly touched on. So what we've done is we've changed that cooling control valve somewhat. We've taken that one actuator out, which was a valve that blocked it off from the engine. And bottom line is that was really not needed. I mean, we were able to warm up just as fast without it. That's really all it was there for. It was just maybe creating complexity when we didn't need it.
Oh, yeah, so like a cold weather start, trying to keep, yeah. Exactly.
But that's been removed, and we still have the same warm up curves though with it. So that's not an issue. It's in terms of like, yes, the cooling control valve, the actuators that we still have in that valve allow us to run the head and the block. We have split cooling between the head and the block. And that's what I mean by, that's when we say that it's running a little hotter, we can allow the head area to run slightly hotter than what the block would. And then overall, what that does is if you can reduce the flow in the block when you don't need that cooling, that's what the valve allows us to do. And if you're not moving water, it improves your efficiency. And all these things, you or your customers, I say, what are you talking about? Well, you do work, you move stuff. If you move water and you move a lot of water because you're hot, it takes power away, right? And that's all fuel economy. So this is what we've done. I mean, in every subsystem of the engine, right, we've tried to optimize. This is why we're getting such high fuel economy numbers.
And so, look, I mean, and just so to be clear, fuel economy numbers haven't been released yet. We're saying they're gonna be good. But what I'm curious about is emissions, because that's been a big bugaboo of diesels and that kind of stuff. And so with the emissions controls, Let me just ask you this very clearly. As emissions tighten up, do you have concerns about this longevity of this diesel engine?
Well, I think there's technologies that we can incorporate going forward to meet additional challenges that we're going to have. And there are challenges. I mean, the EPA has, they have targets for us that we have to meet in 27, 28, 29, 30. There are plans for us to continue to rise up to those challenges and be able to provide products that our customers want. I mean, GM's got a goal, right, of being to try and get into EV 100%, but there's a journey along the way, right? Mm-hmm. And until we have solutions for all of our customer groups, right, we're still going to provide those options when you have to have them. And towing, trucks, this is one of the areas that's very still not 100% there, right, in terms of EV for some customer use cases. Right. So we're going to continue to be in that space until we can get there, and we're going to do it with the best emissions that we can along the way. We don't want to have the customers penalized for that effort. So that's why, things like this, you talk about emissions along with these changes, we've given higher horsepower and torque. We've also had changes to the after treatment for us to be able to get our emissions a little bit lower as well. And they've been really, quite frankly, in this case, they've been really good changes too. We've been able to take some learnings from the LM2. That was a brand new architecture exhaust layout for us. We watch warranty all the time, and we know a few things that needed some correction and adjustment, and we've been able to put that into some of the parts now into this engine. So I'm really kind of optimistic that even though you might say, oh my gosh, it's cleaner, it has lower emission, but I think it's going to have even higher reliability because we've been able to put the learnings from the LM2 into this LZ0 after treatment system. And it's really, from my perspective, it's much welcomed, and we're doing things, learning from the past, and we're doing things even smarter with this engine.
Yeah, I think it's always interesting. You bring up looking at warranty issues and warranty things coming up. People always email me like, hey, let Chevy know about this, or let GM know about this. I'm like, guys, when I do these videos, they know. You guys are ears on the ground. You guys are paying attention to stuff, which I think is great. So let me get to a couple things as far as warranty issues that have been controversial items of this engine, the LM2. And I'm going to see what you've done for the LZ0, which is just a cool name. So I reported on this a few times. Customers complain about long crank, slow start. It's I forget what the wheel was, actuator wheel was an issue, things like that. Did that become a big issue for you in warranty? Was it one of those things where a few people cried wolf and all of a sudden became a big issue?
Well, like I said, we watch warranty. We know there was a sharp increase in those complaints that were coming in at the time. Quite frankly, it was a supplier issue with some of the tooling. In the way this problem manifests itself was very, very difficult, and you'll read some of the blogs and that it was very intermittent. Mm-hmm. The customers would have this happen. It would crank for 10 to 15 seconds, and then it wouldn't start, and then they could go back and start it the next time. They bring it into the dealership for the concern, and the dealer was never able to recreate it, or in the majority of times they couldn't recreate it. It's because of, and the reason we didn't catch it in our own internal systems is because the engine spins down and can stop at just about any rotation. Okay, there's a sweet spot of about 2 to 5 degrees where if it stops in that range with one of these exciter wheels that was bent slightly, could in essence trick the system into reading the wrong position of the cam relative to the crank. It was a very, very difficult one to find. I was deeply involved with getting to the answer on that, Tim, and we finally did. The best solution that we saw was not to replace everybody's target wheel, and what we took advantage of some of the controls, and just by allowing it to spin one additional time before we fuel, it allowed the sensor to learn fully the entire 360 of that ring. And then it's very advanced, actually. I mean, you think, wow, what simple thing, right? But it's very advanced. We actually adjust the magnitude of each tooth that we read off the first rotation. Every startup is a new event for this. So every time it starts new after you had been shut off, it has to read this target wheel, and it reads the amplitude of each tooth. And before we were able to just read the first two teeth. If we read two teeth, we're good to go. We know where it's at because of the way this is designed. If the tooth is bent, it can trick our sensor. So we let it go around one more time, and it learns all of the teeth and the amplitudes of each one of the tooths. And then it knows which rotation we are on the cam versus the crank. And then once we've incorporated that solution, and there is a cal released for the vehicles that were affected by this. It is nearly 100% clean kill on it. Really no downsides for the customer. I mean, they have a 0.4 of a second longer that it takes them to start the car. That's it. But it protects them from that no start issue.
I tell you, everybody I've talked to that has that engine, they all say, yeah, my truck did it, or my SUV did it, whatever, my Tahoe. I'm not getting rid of it though. they're like, I love it. They don't think anything of it. It's just a little annoying sometimes.
Yeah, well, and that's what it was. And the good thing is I don't know of anybody that was stranded from it. It would not start one time, and then you go back and hit it, and it would start. And that was we had full understanding of how it happened. Since then, we've worked with the supplier, we've got the tooling in place, and everything's back to normal now. So
fantastic. I don't cross that item off my list and never talk about it again.
The LZ0.
Okay. So the other question I keep, I'm just curious about this because you and I talked about this when the engine first came out, the controversy over the belt on the back of the engine and drop transmission to inspect the belt. Did the LZ0 make any change to the belt versus gear versus was it a chain? Was the three choices?
Right. So I can tell you, no, we haven't.
Okay.
Those architecture changes are huge to this engine. I mean, the whole oil pump and oil system is integral into the engine, right? And if we were to move it, there's some suggestions. Why don't you go with an external one? Why don't you put it up front? To make that easier access. Easier said than done, and it would take an entire redesign of the block to do that, and the whole cooling system and the whole oil system. Having said that, we picked that choice for lots of good reasons in the first place, and it still was the right choice to do. What I am able to offer or to communicate today to the customer is that for the LZ0, we have now validated that belt to 200,000 miles of service interval. So we've been able to increase it by 50,000 miles recommended servicing of the belt now.
Wow, that's impressive. I mean, I know I'll still get the comments below, but guys, think about this: 200,000 miles. If you drive 10,000 miles a year, that's 20 years. And chances are, at that point, you're going to want to take the engine apart a little bit, anyways, and inspect other stuff. So I don't think it's that big of a deal. So we addressed those kind of things. I have one last question for you that I thought it'd be great to ask you because I keep getting asked this question time and time again, and it's really this marriage between electric and diesel hybrid. Now, it seems to me a little bit weird because a diesel does well at low torque, a hybrid does well at low torque, diesel does well at high, it just seems like it's a combination that's a little weird. But what's your thoughts on the diesel hybrid as you look across the industry and look across, these electrification going on?
Well, it's interesting. I mean, it certainly can be done. We are leaving open all of our options as we're going forward through 2030 as the stricter emissions come in. We don't have at this time any indication what we're going to do with that. So we keep all of our options open. We're looking at different technologies to hybrids they can be fairly expensive. I mean, at the end of the day,
I feel like we have an expense, we have a weight issue with the battery too. You got to figure out.
There is, and there are additional technologies which we feel that the diesel can pursue as we go forward to even reduce emissions, but not penalize horsepower and torque. and do it maybe at a more cost-effective manner. So, like I said, we have a lot of studies going on, and believe me, hybrids are not off the table, but right now we don't know what avenue we're going to go in.
Sure, that's fair. I didn't expect you to give me the yes, it's launching tomorrow kind of deal. I just, it's just interesting. It's just a conversation keeps coming up. I mean, you think about it more and more hybrids coming out. It seems like it's something's going to have to happen at some point.
Yeah, it's interesting that, that's just more complexity, right? With a hybrid. So it's very interesting technology. There's benefits, there's downsides. We haven't picked any direction yet where we're going to go with this.
Okay. Well, it says the last item in the press release, which I printed out at 6-point font for whatever reason, says you're going to start assembling at the General Motors Flint engine operation and be available on select trims of 2023 Silverado 1500 by the end of this year. Mm-hmm. Well, you boys better get ready. I want to drive this thing. Let's go.
I heard you wanted to order one, so
I do. Want to. I'm thinking about buying one too.
Yeah. So right now, Tim, we're in the capture test fleet. The saleable trucks have been built. They are pretty much all released to our engineers and across GM. I'm driving one right now. It's a great driving engine still, and even better with the more power. So I think to sum up the LZ0, it's all the goodness that we had with the LM2, given a little more power. The final fuel economy ratings are not out yet, and they're going to be, it's going to be in the same ballpark of where we were with the LM2.
Sure.
I will tell you that the engine itself is slightly, the BSFC is slightly more efficient than the LM2, just a little bit. So you can expect very similar results coming out.
All right, hold on. You just threw lingo at me. BSFC.
The base specific fuel consumption map. Yeah.
Wow. I did not have that on my marketing bingo card.
Yeah. I'm sorry. That's maybe too technical.
It's fine. It's awesome. So the smile on your face tells me that this is something I should be excited for. Well,
I think so. It really is. We have all the hope in the world that customers are going to be excited for it. We've made enhancements that we feel that the quality will be even better, and reliability will be better. So yeah, it's been a really good development cycle. Things have gone quite smoothly, and just overall, I can't wait to get it out there.
All right, fantastic. Can't wait to see it. Can't wait to drive it. Can't wait to enjoy more of it. So hey, thanks for joining me.
Yeah, you're very welcome, Tim. Appreciate all your efforts, and keep up the good work there at Pickup Truck and SUV Talk.
There you go. All right, for more, check the videos over here, website down below. As always, thanks for watching. I will see you down the road.